All right, matrix multiplication, it says the product AB in that order. And there's an importance for him to say that order because the multiplication of matrices is not commutative. So the product AB in that order of the M by N matrix A and the N by L matrix B is the M by L matrix C. Something from CSEC. So here is telling you that the matrix A is a M by N matrix. A is an M by N matrix, and you're multiplying it by B, which is a N by L matrix. So this makes them compatible for multiplication, or you can say conformable for multiplication. That makes them compatible. And this is the order of the matrix product. So the number of rows in A, M, by the number of columns in B, L, is the order of the product, and the product is C. So you have AB is equal to C. The number of columns in A must be equal to the number of rows in B, and the number of rows in A by the number of columns L in B gives you the order of the matrix product. So here's the note. AB exists if and only if the number of columns of A is equal to the number of rows of B. That is, A and B are conformable for matrix multiplication. So the thing that makes them conformable for multiplication, the matrix product only exists if the number of columns in the first matrix is equal to the number of rows in the second matrix. Now, when finding the product AB, the rows of A are multiplied by the columns of B. So when you're multiplying two matrices, you multiply by row by column. You multiply the rows of the first matrix by the columns in the second matrix. Matrix multiplication is not commutative. So AB is not equal to BA. All right, so example 10. All right, so let me just do some multiplication to jog your memory. Can we multiply the following matrices? If we can, find the product. All right, well, let's find out. In A, the number of rows is 1. So in A, the first matrix is a 1 by 3 matrix. And you're asked to multiply this by a 3 by 1 matrix. So yes, it is possible to multiply the two matrices because the number of columns in the first matrix, 3, is equal to the number of rows in the second matrix, which is also 3. And when we multiply these two matrices, we're only going to get one element. And a matrix with only one element is called a singleton matrix. So when we multiply, so it's 1 row by 1 column, so we're going to get one element. Whenever you multiply a row by a column, you're going to get an element. So if you multiply 1 row by 1 column, you're going to get 1 element. So this is the first element, second, and this is the third element. First element, first, second, third. How do we multiply a row by a column? It is the first element in the row multiplied by the first element in the column. The second element in the row, plus the second element in the row by the second element in the column. So in the case of A, we have what? 4, 3, 1, multiplied by -2, 3, -2. So these two matrices are conformal for multiplication because the number of columns in the first matrix is equal to the number of rows in the second matrix. We're multiplying one row by one column, so we're just going to get, the answer is just going to be one element. How do we multiply a row by a column? First element in the row by the first element in the column. So it's 4 times -2 is -8. Second element in the row by the second element in the column. So that is what? 3 times 3, which is +9. And then the third element in the row by the third element in the column, which is 1 times -2 is -2. So this is our answer. This is 1. 1 -8 plus 9 is 1. 1 minus 2 is -1. The answer is -1. All right, so let's have a look at B. So in each case in example 10, we have to first determine if the two matrices are conformal for multiplication. Then we are to multiply the two matrices if they are conformable. So let's have a go at B. In B, we have a 3. We have a 3 by 1 matrix, and we are multiplying it by a 1 by 3 matrix. So the fact that the number of columns in the first matrix is equal to the number of rows in the second matrix, that makes them conformable. So the next thing we're going to do, so they are conformal for multiplication. So the next thing we are going to do is we're going to multiply them to determine the matrix product. We have 1, 3, 2 multiplied by 4, -2, 0. All right, so we're going to multiply a row by a column. So we're going to multiply a row by a column. Every time we multiply a row by a column, we get an element in the answer. So the first row, which has only one element, we're going to multiply 1 by 4, we get 4. First row, second column, 1 by -2, we get -2. First row, third column, 1 by 0, we get 0. Second row, first column, 3 by 4, we get 12. Second row, second column, 3 times -2, we get -6. Second row, third column, 3 times 0, we get 0. Now, the final row, third row, first column, third row, first column, 2 times 4 is 8. 2 times -2 is -4, and 2 times 0 is 0. If you multiply a 3 by 1 by a 1 by 3, you're going to get a 3 by 3 matrix. C. In C, we have a 3 by 2 matrix, and we're testing if we can multiply it by another 3 by 2 matrix. And the answer here is what? No. So for C, the two matrices are not conformable for multiplication. And the basic reason for that is that the number of columns in the first matrix is not equal to the number of rows in the second matrix. All right, example 11. So in example 11, we're asked to multiply a 3 by 3 matrix by another 3 by 3 matrix. The two matrices are conformal for multiplication, 1. And if you multiply a 3 by 3 matrix by a 3 by 3 matrix, you're going to end up with another 3 by 3 matrix. So let's multiply. All right, so whenever we multiply two matrices, we multiply the rows of the first matrix by the columns in the second matrix. So some people normally like to do this. Now, whenever we multiply a row by a column, we get an element in the answer. How do we multiply a row by a column? First element in the row, first element in the column. So that's 1. So multiplying the first row by the first column, 1 times 1, 1. 2 times minus 1 is minus 2. 3 times 3 is 9. I just multiply the first row by the first column. Next, I'm going to multiply the first row by the second column. 1 times 1 is 1. 2 times 2 is 4. And 3 times 3 is 9. First row, third column. Our top row, third column, we're going to get the top third element. Our top row, right column, we're going to get the top right element. 1 times 2 is 2. 2 times 1, minus 1 is minus 2. 3 times 2 is 6. So we need to be careful not to make any errors. Second row, first column, 2 times 1 is 2. 0 times minus 1 is 0. 1 times 3 is 3. Second row, middle column, 2 ones, 2. 0 times 2, 0. 1 times 3 is 3. Okay. All right, next. Middle row, right column, 2 2s, 4. 0 times minus 1, 0. 1 times 2, 2. Now, third row, bottom row, left column. You're going to get the bottom left element. 1 times 1, 1. Minus 1 times minus 1, positive 1. 1 times 3, positive 3. Bottom row, middle column. 1 times 1, 1. Minus 1 times 2, minus 2. 1 times 3, 3. Bottom row, right column. 1 times 2, 2. Minus 1 times minus 1, plus 1. 1 times 2, 2. That will make our final answer. 8, 5, 5, 14, 5, 2, 6, 6, 5.